Well, hello everybody. Welcome to Blue Marble Science. How much do you know about magnetic declination? Well, whatever it is, I'll bet it's more than Brian's logic knows. Hey, warning, severe facial and monitor damage alert is in effect. Get out those oven mitts. Push the monitors back out of punching range. And let's listen to Where's Wally, and then we'll have some fun.
G'day everybody, it's Where's Wally here. I want you to imagine it's 1 a.m. and you're trying to fall asleep. What are you going to do? Well, do what I do. Go and listen to Nathan Oakley. Now, he's a guaranteed cure for insomnia if I've ever seen one. Same old stuff, same old boring things, every day. Well, almost. I heard the voice of Brian's logic. He was finally getting around to answering my question about magnetic declination and QF63, my video about the flight that Greater Sapien took. But oh, what derp that followed. I know this needed to be addressed, but I was not able to, so luckily I knew who to call. But unfortunately, Dr. Bob had only just slapped Brian around a bit, so he was out. Never fear, I knew who else to call. But Wolfie, he'd been wet and wild all day. I hope that meant it was a theme park. But then again, I have a third, and it was Blue Marble Science. Actually, I kid you. Blue Marble Science was the first one I let know, because I knew he would want to know, and he would know exactly what to do. Blue, have a listen to this little bit of derp, and have at him. Thanks, mate.
Everywhere.
I'll fill in the time between John and Brian. The 90-degree that you must minus is a right angle. So the sextant and all the operations talk about the zenith. So that's a 90-degree. The observer zenith is a 90-degree. The GP of the star or sun or moon is a 90-degree, if you can bring that down as a GP. That could happen only on a flat plane. So 90 degrees, every time you see that, and I'm seeing it all over the place in the books I bought and the PDFs I read, videos I watch. Oh, minus this from 90, subtract this from 90. You got to take no more than 90. That's the maximum altitude is 90.
Wait a minute. Here's Gary Weibing explaining that angle to Dr. Bob.
All right, Gary, you understand 90 degrees is directly over your head, and I can measure down to the sun, right?
Well, 90 degrees is also if you're looking perpendicular to the ground. Parallel to the ground. Yes.
90 degrees is straight up. 0 degrees is at the ground. All right.
Well, the ground is 0, straight up. Yeah.
Gary, I'm not going to
out. No, straight up is 180 degrees. Straight forward is 90 degrees.
He's full of shit.
No.
Yes.
I'm not going to argue with you about it. Straight above
that's a half a circle. So half a circle is 180 degrees. That would be straight up.
Gary,
it depends on what you're trying to say.
I'm saying it correctly. So why don't you listen to what I'm saying?
From the ground to straight up is 180 degrees.
Gary was eventually forced to admit that he was wrong, but he didn't go down without a fight. Okay, anyway, we got beyond that, so now the real show starts.
That's just crying of a flat surface. Has to be. You can't get it on the curve of chasing a 90 degree.
Shh, don't mention 90.
I'm ready. Sorry.
Go ahead, Brian. I'm ready when you are.
Yeah, I'm ready to go. I'll make it quick. Yeah, this is about magnetic declination, as it's been currently in my chat, in my comment section, by a lot of the globe side. It's been denied. They're saying it doesn't change the distances between two locations. So how can you change the actual direction of a location, but not change its distance between that and another location?
You've got to be shitting me.
No, I am not shitting you.
Brian, once again, you've managed to totally confuse yourself. Magnetic declination doesn't change the location of positions on the Earth. Locations are given by the latitude and longitude. If I'm in Atlanta, Georgia, and I want a true bearing to Denver, Colorado, it's that line right there. If I'm in Houston, Texas, and I want a true bearing to Denver, Colorado, it's a line that looks like that. Magnetic declination does not change those locations nor does it change those bearings. Magnetic declination simply tells us how much adjustment we need to make to a magnetic compass reading to account for the fact that the north geomagnetic pole is not coincident with the north geographic pole. We'll go into that more in a minute.
So I just put this out here, right? Remember, this is measured in degrees, right? So Sydney is plus 12.71 degrees positive east. Johannesburg is minus 18.97 degrees negative west. 12.71 added to 18.97 equals 31.68. 31.68 by 60 nautical miles equals 1900.8 nautical miles. 1900.8 nautical miles equals 2,187.4 statute miles. So according to magnetic declination, Sydney, Australia is 1900.8 nautical miles or 2,187.4 statute miles further from Johannesburg than we are led to believe by the Globe Earth model. Because they have no declination within their model.
Brian, you clearly have no idea what magnetic declination is. Let's go through this and see if we can straighten you out. Our compasses, our magnetic compasses, point at the north geomagnetic pole. The geomagnetic pole is about 1,000 miles away from the north geographic pole. It's in actually northern Canada. We need a way to correct our compass readings for this misalignment, and that's what magnetic declination does. The Earth's magnetic field is very complicated, but a simplified model just looks like a bar magnet running right through the center of the Earth with antipodal north and south poles. Now, as we saw before, the magnetic North Pole is not coincident with the geographic North Pole, or the rotational pole as they call it in this graphic. Because of that, we can have a magnetic declination that is west of true north, as you see here, and that's considered a negative declination. Or we can have a declination that is east of true north, as you see here, and that's considered a positive declination. Here's a map of magnetic declination for North America for the year 2010. The black line you see down the center is the agonic line. That is the line of no magnetic declination. If you're along that line, magnetic north is the same as true north. But if you're east of that position, to the right of it, the declinations are negative. That's indicating that the compass is pointing west of true north. On the other hand, if you're left or west of the agonic line, those declinations are positive. That's an east declination. That means the compass needle is pointing to the east of true north. Here's a graphic that may help visualize this a little better. The outer ring is showing true headings. The inner ring is showing magnetic headings. Now this example is set up for a magnetic declination of 4 degrees 15 minutes west. That means that the magnetic pole is west of the true north pole by about 4 degrees, as you see up here at the top. That means if I want to travel along a 300 degree heading, as I'm showing you here, I would have to travel along a 34 degree magnetic heading. This is what magnetic declination is used for. We don't add magnetic declinations together, and we don't try to calculate distances with them. It is simply a correction from a magnetic heading to a true heading. Here's a real world example, the one we used earlier. If I'm in Atlanta, Georgia, wanting to travel to Denver, Colorado, the true heading I need to fly would be 295 degrees. But I've got a 5 degree magnetic declination, 5 degrees west. I've got to add that to the 295 degree true heading to get a magnetic heading of 300 degrees. If I mess up and don't include that magnetic declination, the heading of my airplane is not going to be the line we see. It's going to be that line. I'm not going to Denver. I'm going to Salt Lake City. Are you getting the idea now, Brian?
So they are denying that magnetic declination has really any purpose. That's basically what they've been denying in my comment section. This is what they're at now, because they have to, because they're trying to support distances with air travel from one place to another, or travel by ship. It's like, yeah, but when we do, it's like that claim where three people, one in Australia, one in South Africa, one in South America, can look at the same star system at the same time. It's that they're trying to support basically those kind of claims, and the only way to support them is to pretend that magnetic declination, which is our only actual north, doesn't exist.
No, nobody's trying to deny magnetic declination, Brian. And now that you know what it is and you know how to use it, if you don't mind, please stop trying to add the damn things together. Hey, thanks for watching. Hope you guys enjoyed it. Don't forget those little buttons down there. Shout out to the patrons and the members and the PayPals. I appreciate everything you guys do. And we'll see you on the next one.